Hi friends, today we are going to perform the practical of TYBSc physical chemistry. Aim of the practical is to determine the pH values of various mixtures of sodium acetate and acetic acid in aqueous solution and hence find out the Ka of the acid pH metrically. Myself Ramdas Suralkar, Assistant Professor, Department of Chemistry, Pratap College Amarne Autonomous. The principle behind this practical are the practical is based on the application of Henderson-Hazelby's equation. By measuring the pH of various buffer mixtures, you can graphically or mathematically determine the acid dissociation constant Ka of the acetic acid. When you mix a weak acid, acetic acid, and its conjugate base sodium acetate, you form a buffer solution. The pH of this solution is governed by the equation pH equals to pK plus log of concentration of salt upon concentration of acid. When the concentration of the salt is exactly equal to the concentration of acid, the log term becomes 0. So log 1 becomes 0 and hence the equation becomes pH equals to pK. In this way we can calculate pK and by from pK we can calculate Ka of the acid. So let us see this practical demo in the laboratory of our college. Today we are going to perform the practical of TYBSc physical chemistry student. The aim of the practical is to determine the pH values of various mixtures of sodium acetate and acetic acid in aqueous solution and hence find out the Ka of the acid pH metrically. So the chemicals required for these practicals are 0.2 normal acetic acid solution and 0.2 normal sodium acetate solution. From these two solutions we have to determine different, we have to prepare different buffer solutions. So buffer solutions preparation can be done by using this preparation chart. So this we have to prepare 5 buffer solutions. They are named as A, B, C, D, E or buffer 1 to 5. So this is the volume given for this buffer solution. So I have already prepared these buffer solutions of different pH by using this chart, and these are 5 buffer solutions. So these buffer solutions are prepared by using this burette. Though you will observe the volume of the volumetric flush will be somewhat less or more, but that volume is taken as per the burette reading. So preparation is already over. Now we have to standardize this pH meter before we start the experiment. So pH meter can be standardized by known solutions having pH 4 and pH 7. So pH 7 buffer solution we have given 7 buffer tablet that can be crushed and dissolved in 100 ml distilled water. That is treated as a pH 7 buffer solution. So add this pH electrode in the 50 ml solution of pH 7 buffer, and then from the back side of this instrument you have to adjust the slope knob to 7 pH, and then remove this solution and add pH 4 solution that is prepared from 0.05 molar KHP solution. Then dip this pH electrode in the pH 4 buffer solution, and then adjust the standardized knob to pH 4 and also the temperature knob as per the room temperature of the solution. Then after standardization of instrument, we have to measure the pH of the prepared buffer solution. So first we will take buffer A solution or buffer 1 solution added in the beaker. 25 ml of this solution is prepared. Now dip this pH electrode into this buffer solution, buffer A solution, and observe the pH of the solution. So pH of this solution is observed to be 6.63. So I am writing here in the observation table of buffer pH A is 6.6. It is now stabilizes at 6.70. Then we have to remove this solution in buffer A and now add buffer B or buffer 2 solution in the beaker. Now dip the pH electrode into the buffer B solution. The pH will be decreased. Why? Because we have added more quantity of acid. We are increasing the quantity of acid and decreasing the quantity of salt. So the pH should be decreased. So pH of this buffer 2 or buffer B solution is 6.42. I can write here 6.42. Similarly, remove this buffer solution. And add buffer 3 solution or buffer C solution in the beaker and observe the pH of this solution. So pH will be decreased and it is the result, expected results are observed. The observed pH of this buffer C solution is 6.25. Now again remove the solution. Now I am going to add buffer D or buffer number 4 into the beaker. Dip this electrode, pH electrode, and stir the solution. We have to note down this table reading of the pH meter. It is come out to be 6.10 as expected. Now last solution of this buffer is buffer 5 solution or buffer E solution. So pH of this buffer solution is stable at 5.90. 98. So these are our observed reading of various buffer solutions, which are expected values are decreasing pH values as we have increased the concentration of acid solution into the buffer solution. So we have to, from this solution, now we have to determine the concentration of acid and salt in this mixture. Now this mixture is 25 ml of mixture of having prepared from acetic acid and sodium acetate. So for this we have to determine the concentration of acid in a buffer mixture. So initial concentration of this acid is 0.2 normal and the volume taken for buffer preparation of buffer A is 2.5 ml and N2 is, we have to determine the normality of this acid in mixture buffer A and the volume of the mixture is 25. So the normality or concentration of this acid in a mixture in buffer A is find out to be 0.02 normal solution. Similarly, for salt solution, concentration of salt in buffer A is calculated and it is come out to be 0.18 normal. In this way, this is for buffer A. We have determined the pH values, concentration of acid and salt in different buffer solutions, that is 0.02, 0.04, 0.06, 0.08 and 0.1 normal, and concentration of salt is decreased because we have decreased the volume of salt in the buffer solution. Now we have to determine the pK of the acids, pK of the buffer solution. For this we have to use Henderson-Hasselbalch equation, that is pK equals to pH minus log of concentration of salt upon concentration of acid. Now For first calculation, pKa1, the pH of the buffer A is 6.70 minus log of salt upon acid. So log of concentration of salt upon acid is find out to be 0.9542. So 6.70 minus 0.9540. So whatever the difference is, we have to subtract this pH from this log of salt upon acid. The pKa1 of the buffer A is calculated. Similarly, pKa2, pKa3, pKa4 and pKa5 of buffer ABCD can be calculated similarly. Now from pK values, we have to take mean of these 5 values and add these 5 values and divide it by 5 to make pK mean. So from this pK mean, we have to calculate Ka value. So the formula used for calculation of Ka or dissociation constant of acid is Ka equals to antilog of minus pK. So whatever the pK mean we have calculated, that can be used here to calculate the Ka of the acid. So in the result, final result of our practical, two observations we have to write. pK of the acid, that is the mean pK value of the 5 buffer solutions, and then Ka of the acid. So this is the end of this practical. Thank you.